So in this lecture, we're going to continue our discussion of methods for finding the equation of the circle. This time based just on a set of coordinates. Right? We know certain points that are on the circle. For example, we may have gotten from some experiment or some other kind of data collection, and we want the equation of the circle that goes through them. Okay, so the first question we have to answer is how many points are enough? So can we do it with two, for example? Well, if we do it with two, I don't think that's going to work. For example, if I've got these 2 points here, that circle goes through them, but so does that one. Right? And if I can continue doing this indefinitely, I can make the circle bigger, kind of flattening out that upper part, and get infinitely many circles that pass through those 2 points. So in general, yeah, 3 is going to be the minimum number that we need to come up with this equation. So I've got an example here for us to look at where I've got the coordinates of 3 points. I want to find the equation of the circle that passes through them. And I'm actually going to use this general form here to do that. So what I'm going to do is I'm going to put each of these coordinates one at a time into the equation. So if I put 1 comma 2 in there, 1 squared plus 2 squared plus a plus 2b plus c equals 0. And this is 5 here, so let's move that over. This becomes a plus 2b plus c equals negative 5. All right, now let's do with the next point. Negative 1 comma 4. If I put those points in here, negative 1 squared plus 4 squared minus a plus 4b plus c equals 0. In this part, that's 17. So negative a plus 4b plus c equals negative 17. And then one more point, 0 comma 1. That gives me 0 squared plus 1 squared. Now, there's no a term here. Plus b plus c equals 0. So that's b plus c equals negative 1. All right, so look at what I've got here. I've got this equation and this equation and this equation. 3 equations in 3 variables. And so I know how to solve this. Conveniently, this last one actually only has 2 variables. So that's kind of telling me what I need to eliminate in the first one. I want to keep b and c. So if I add these two together, I'm just going to write them over. A plus 2b plus c equals negative 5. Negative a plus 4b plus c equals negative 17. If we add those together, the a's go away. 6b plus 2c equals negative 22. Let's clean that up a little. Divide through by 2. 3b plus c equals negative 11. All right, great. So now I'm going to take this third equation here. I'm going to multiply that by negative 1. This turns into a minus b minus c equals 1. And if I add these together, that's nice. The c's go away. 2b equals negative 10. B is negative 5. Okay, so now let's drop that into this one. Negative 5 plus c equals negative 1. Add 5 to both sides. C equals 4. Right, so now I'm going to go back up to this equation here. I'll go back to the first one. A plus 2 times negative 5 plus 4 equals negative 5. So this is what negative 10 plus 4 is negative 6. Add 6 to both sides, and we get a equals 1. And that's all I need. Right now, I'll drop those numbers into here, and I'll have my equation. X squared plus y squared plus x minus 5y plus 4 equals 0. I've got another example here for us to look at, and I'm going to warn you up front. I did not just pick this to get another practice one in here. Something unusual is going to happen when we get to the end. So just kind of bear with me as we walk through this process. So I'm going to start the same way. I'm going to start with 1 comma 2, put that into the equation. 1 squared plus 2 squared plus a plus 2b plus c equals 0. So that's a plus 2b plus c equals, move that 5 over, and that's negative 5. All right, so we put 2 comma 4 into there. It's 2 squared plus 4 squared plus 2a plus 4b equals 0. So this is 4 and 16, that's 20. 2a, whoa, I lost the c, excuse me, slip a c in there, plus c equals 0. Okay, so that's 2a plus 4b plus c equals negative 20. We'll do this one more time. Negative 2, negative 4. That's negative 2 squared plus negative 4 squared. That's also going to be 20. Minus 2a minus 4b equals 0. So minus 2a, I keep leaving out the c's, excuse me, plus c equals 0. Minus 2 minus 4b plus c equals, what's that going to be? Negative 20. Okay, we're about to get into trouble. Let's take these two equations and combine them together. 2a plus 4b plus c equals negative 20. And I've got negative 2a minus 4b plus c equals negative 20. All right, so far we're looking okay. All right, this is going to give me 2c equals negative 40. C is equal to negative 20. Now I'm going to take that and I'm going to put it into the first two equations. So the first one becomes a plus 2b minus 20 equals negative 5. That's a plus 2b equals, add 20 to both sides, 15. Okay, now let's do it to the second equation. 2a plus 4b minus 20 equals negative 20. So 2a plus 4b equals 0. Divide through by 2. A plus 2b equals 0. And now we really do have a problem. Look at these two equations. A plus 2b equals 15 and a plus 2b equals 0. Well, it can't equal two different numbers, right? If we try to combine these together, do minus a minus 2b equals minus 15, and you get 0 equals minus 15. So there is no solution, right? Okay, what happened? Well, the answer is there is no solution, right? There is no circle that goes through those 3 points, right? And to see why, it helps to graph them. Once you've got a picture of those 3 points, you can see pretty quickly that those points are collinear, and that's a problem. You can't draw a circle through 3 collinear points. So this is a special case you need to be aware of. It's almost worth just graphing them first. Just do a really quick check, make sure they aren't on a line. Then you can go on and start working with the equations. And if you don't do that, that's fine. You'll see what happened in the last one, where the system of equations just ends up being inconsistent and you don't get a solution. So that wraps up our discussion of circles. And in the next lecture, we're going to move on to the next conic section and start talking about something called parabolas.